Hello everyone, welcome to Watch Complications. I hope you're well. We're all in lockdown right now thanks to COVID-19, but I really do hope my subscribers and those of you that might be watching are doing well and staying healthy and socially distanced, not necessarily socially, more like physically distanced. We're still all communicating and talking with each other, hopefully, to stay sane. So this is another video in my Making Custom Watches series. This is a special project that I decided to take on. Now, a lot of people email me and ask me if I'm willing to do a dial modification or make a custom watch. I choose particular people I'm wanting to work with based on personality and timeline and a lot of other things, what else I've got going on. This is a project someone contacted me about. They didn't need a particular full design. They didn't need a dial modification. They needed a movement holder. And I've done some other videos that have shown, whether it was with my dual time watch, my glass parallel, which is projects. I'll link to those in the description below and the videos about those. But I've made custom holders before for movement. Certain cases are made with a certain movement or a size of movement in mind. And if you're wanting to make a custom watch or a low run series of watches, you're not going to spend the time, money to invest in creating a new custom case, which is an expensive proposition for a one-off sort of watch. You're going to try to find a case that exists or you can buy on the open market, whether that's via a watch parts distributor of some sort or something like eBay. You'll buy a case, but a lot of those cases aren't made to hold a variety of types of movements, just a particular type of movement, whether that has to do with the diameter, the height, and a lot of other factors. Well, this person contacted me and said, I have this particular case I want to make for, let's say, 30, 50, 100 watches, and I want to use this movement, but I can't find a movement holder on the market that will hold this particular movement in this particular case. Can you help me out? And I've done enough work with AutoCAD 3D printing. I said, this is exactly the kind of project or person I wanted to help. So what you're going to see in this video is the process that I go through to, one, go from here's an idea, I want to fit this movement into this case, and how I go through the design process. I'll show you the iterations and the prints of how I go about doing that so that we can marry those two things together, a particular movement in a particular case. A couple things as we sort of get started here. Make sure you visit the website, watchcomplications.com, and follow me on Instagram at watch_complications, and subscribe if you haven't to the channel. Ring the bell if you want notifications. Also be sure to check out the watch app, Watchy, if you care about managing a watch collection digitally. So I hope you get a lot out of this video. Wrist check today. I'm wearing a very beautiful watch. You've seen this before, my Atelier Win, which is a porcelain. This is the How Green edition. It's a beautiful watch. Porcelain dial. It's my porcelain dial watch in my collection, and just a lovely watch. Just simple three-hander, you know, with a small seconds at 6. It's green. I love the green suede strap. I'll link to that video in this one, and so be sure to check that out. So let's take a look at my process for creating custom movement holders in my Making Custom Watches series.
So for this project, the customer wanted me to find a way to fit this Miyota 2035, a simple three-hander quartz battery-powered movement. Now, in a lot of my own watches, whether I buy or that I build, I prefer mechanical movements. I work with quartz sometimes, but I just don't prefer it. But this was a project I felt like I really wanted to take on, was fitting this movement into a particular case that this customer was going to buy off of eBay. And I really do like this case design. It's a 40 millimeter. It's a nice size. It's mostly polished. It's got a nice ergonomic look about it. It's got a nice height. It's nice, but this is meant for a mechanical movement. And the holder that comes with this watch is a design that is meant to hold a mechanical movement. This is the width. You can see I think it's 11.5 in terms of the size. And so that's the holder that came in the case. It's down in there, right? It's the right height for, you know, you can see just above the edge. So this is the holder that came with the case. Not meant to hold this 2035 Miyota. Again, this is a standard size that's used for a lot of quartz movements, particularly Miyota. It's like a funky oval. How can you get this movement to fit into that case when it comes with this holder? Well, you can go to the third-party market and try to figure out if there's a movement holder that exists that is meant to marry these two, but that's probably not going to happen, not likely. So how do you go about building one of your own? Or finding someone like me who can do it? The design process for this watch was I did have a couple of movement holders in my random collection that are meant to fit these Miyota movements. Now this one, you can see the edge of this sits just above the surface, not flat. And those sort of little dimensions matter in terms of height, particularly when we talk about stem height inside the case. Okay, so I had this one, and both these provided me the same feature, and that is something I can use my digital calipers against to measure the diameter and the lengths of the movement. This one, a little bit nicer, you can see has been designed so that the metal surface of the movement sits flush, so the dial could sit flat on top of that. Either way, I used these couple little movement holders I had in my random set to help measure the dimensions. So let me walk you through the process. I was thinking, okay, I've got this case, it comes with this holder. Let me create something that just fits inside of this so I don't have to worry about external dimensions. It'll fit down inside of this movement holder, and so I can lay the movement inside, and there we go, right? So first thing is getting this thing designed correctly. As I said, I used these other existing holders to create the dimensions, drew those up in AutoCAD, show you that in a second. This is just showing the series of prints. So I've got these laid out in order. These are test prints I did as the design evolved, boom, boom, and then I'll get to these other pieces in a second. But here's my sort of evolution process up here at the top. So first one, you measure, you get close. 3D printing is not a perfect science, depending on the printer, the material, etc. This one was close, just a little bit too small. So then I scaled that up a little bit and led me to this second design, which was just right. It fits in there. Only if you twist it at an angle will it fall through, so it sits in there pretty tight. And that's what the reverse looks like. Print it out. You can see I have this little lip, this edge around here, and that's so that it sits inside of the existing movement holder that came with the case. So this is made to sit inside. The next thing I had to worry about is, okay, this needs to sit at the right height. It needs to sit flush with this so the dial can sit flat on top. So as I went through this process, you can see this doesn't have any cutout for the stem. So that's great. I designed, I've got this fitting after the second print. Then I need to think about, okay, I need to cut a hole in this or a gap so that the stem can come through my movement holder, which is already existing in the existing one. So then I go through the process of doing that, and I was going to see, okay, do I need to cut the entire thing? How much of this do I need to cut out for the stem clearance? Is this enough? Or do I need to cut the whole thing out? Turns out I need to cut the whole thing out. So I go through a couple iterations of that, and also getting the height correct so that it sits flush with the surface. So you're going to go through multiple iterations of this. Big things to watch for are things like, okay, do I need a cutout for the stem? If so, at what levels? And making sure that this is flush so when the movement's sitting down that this is nice and even where the dial's sitting on top. So I got to this point, right? Okay, marriage of the two holders. Got our movement over here that sits in top. It doesn't fall out unless you put it through an angle. It sits it's just the right size to hold the movement. And there we go. Okay, looks great. Now, let's try to put this together in this way. Problem is, as I came to find out, and I kind of knew this going into it. Let's say I have a dial that's 0.4 millimeter thick, which is kind of the standard dial size, and I'm just going to set that down inside the case. This is just a rough 3D print. This is 0.4 millimeter thick. I used it for some testing pad printing. I've cut it roughly with scissors so it'll fit inside of this case, which is about 33.5 millimeter for a dial. Okay, so that's sitting down inside the case. But now let's put this all together. We'll set the movement holder down there, which holds it perfectly. And then we've got the existing movement holder. Again, sits in place. This has got a couple issues. One is, if you turn this and you were able to look down through this hole correctly, like I have to use magnification, right, so you see really close, the movement's not at the right height. Yeah, it's here where you can see the the pins coming through, put the hands on, but it's not even so that this goes in level, so that the stem goes in level this direction. You don't want a stem going in at an angle. That's just not good for any reason. The tension, it'll snap, it'll break the movement, etc., etc. Anyway, so we need to raise the whole thing up. How do you do that? Well, you print a ring. This is 1 millimeter. I needed to raise the whole thing about 1 millimeter so that it would fit correctly. So at this point you're thinking, okay, I got the movement holder that came with the case. I've created this little fitting to go inside of it that holds the movement, but now I got to raise the whole thing. And I've had to do this for other watch builds before, specifically my dual time watch. I had to create a little ring, and these are different versions of the ring as I was printing. See, sometimes on a 3D printer you're going to get sort of weird things like this. You can see how that's kind of not printed cleanly. What you have to do is play around a little bit with the height of the ring plus the detail, high detail versus standard detail versus ultra high detail. I'll talk about that a little bit more when I show you this in AutoCAD and Cura. So what I had to end up doing with this was 1 millimeter distance between the internal and the external side of the ring wasn't enough. It needed to be 1.2, and then I could do a 1 millimeter height without it doing sort of funky bending or warping and that sort of stuff. And it gets me down to this, a nice perfectly shaped ring that is from interior to exterior 1.2 millimeters in terms of the diameter of the circle of the interior versus exterior, and it's 1 millimeter high, which is how high I needed to raise that so that the movement was sitting at center. And this fits just perfectly inside the case and against the center ring. You've seen me do this again with the dual time watch that I built for a customer. This just fits. And in fact, it almost takes the pressure of the dial on top and being able to push it down evenly across that it fits, which is just what we want. Okay, now you're going to see that ring on the interior, which is good. It kind of forms a nice contrast around the dial. You can see that white ring in there. What that's going to do is it's going to raise everything a little bit so that that movement is sitting at center, vertical middle, so that the stem goes into it evenly. Put in the movement here, lay it flat, and then we'll put in our little holder that I come up with in my first series in terms of the design. There we go, sitting at 3 o'clock. And then we have our movement holder that came with the case. Now, that's going to get us the movement. It's pushed everything back. You can see there's still plenty of clearance for the pins because all I've done is put a spacer ring, a cushion ring in here, sometimes called a chapter ring. And now the movement is going to be sitting at height. There's the hole. You didn't see it that way before, but it's really clear now because now it's at center. That's great. What's the problem now? The case back isn't going to fit because the movement holder that came with the case was meant for a certain height, and I've now changed that height by 1 millimeter this direction. So now the case back's not going to fit. That means if I'm going to put a ring in here to push everything back, I'm going to have to come up with a movement holder that's shorter. So scrap this, goes into the pile, and got to come up with a different plan. Now I've got my ring in here. This is one of the rings that is actually sort of the final production. Got my dial and my movement. I'll just set those down in here for now. So then I needed to not just design this little piece that sits interior to this. There's this little ledge in here. See that little ledge? I thought it was pretty clever. Like this. Got a little lip around here, right? Fits inside there just nice. Just so. Look at that. It's a nice fit. Looks good. Wasn't gonna work. So that gets thrown away. Come up with a new design, right? The movement holder myself, which matches a little bit more closely with the height of this exterior one, only just a little bit shorter, right? So that the case back can fit on. And I go through the same process. I create the holder that's a little bit, redundant. This, so see that little notch inside the case across from 3 o'clock. So at 9 o'clock, see there's a notch. That's just so you can create a little flare out on the plastic so that when you put it in there and you start putting the case back on or movement or things, it doesn't move around. The rings don't rotate. So there's a little notch in there to help for that. So that's on here. So you recreate those little things. So basically I took the concept from my previous ring, right? And I just extended the edge, put the little notch on it, and then made this taller, but not as tall as the one that came with the case so that it would fit with the case back. Then the question then comes up again, okay, got to get the holes cut for the stem correctly so that it can go through the case and into the movement with plenty of clearance. This is one without any extra cutout. I basically just added the extra layer here, and then I went through a process. Okay, is there a little bit I could trim off? You can see there's a little notch there. It's cut a little bit lower. This one's solid down. This one has a notch a little bit lower. And ends up that what I decided to do was just what was best to do was just to create the entire gap so there wasn't any interference with the stem going into the movement. And this is the final design I ended up with. So this is the right height. Kind of compare it to this. You can see it's a little bit shorter. Remember, because this has a millimeter added to it, which will bring it up to height. And we have the notch, 9 o'clock. We got the cutout for the stem right there, but this is of course designed to hold this specific Miyota 2035 movement and a lot of other quartz movements, both Miyota and other brands. Okay, so I made this, and it's the whole shebang. This has the notch. Got to put it at an angle so it fits into the notch, fits in there nicely, and the movement sits in there just enough. Unless you push hard, it's not going to necessarily fall through. So I'm not holding it in. It's just the right size. If you angle it just a hair, it will fall through. Stem goes in there. So that's what it looks like from this direction. I'm going to pop this out, and it's just easier to align it this way inside the case. Put that down. Angled this in at 9 o'clock into that notch. Fits in place. There we go. Looks nice. And now look. That's at about the same height that it was, just above the edge of the case, with the movement holder that came with the case. It's just I've 3D printed this one, okay, just above it, which means that my movement is going to be at the right height. Remember, I got the 1 millimeter high ring in there, movement's at the right height, and now I don't have interference. The case back can go on correctly. Now, if you want to add, I could leave it like this, screw the case back on, put the stem in. The issue is this had an exhibition case back, so you're going to see the quartz movement. Yeah. And you know, quartz movements aren't that wonderful necessarily to look at. I mean, they're okay, but you know, it's not like looking at a mechanical movement, which is a whole nother ball game. The stem's going to be holding it in place to a certain extent. So you get the stem coming in, the movement's not going to fall out or move around, but it looks kind of weird, and also you want to add some extra security there for the movement, so it you know, say something happens. Say you take the stem out for maintenance or something. You just don't want it to fall out. I wanted to make a cover for this so that it would secure it a little bit more, keep it from rattling around when you're shaking your wrist, and just added a visual cover for it. So when you're looking at it through the exhibition case back, it doesn't look so weird. So then I went through a process of, okay, you can see I've got this exterior ring around the structure for the movement itself. And there's a gap, and then we have the height for the case back closer to the edge. So I thought, well, let's create a little cover, right, to go on top. Boom, right? And a person could paint this, they could put their decal on it, they could put a logo on it, that sort of thing, but it's a lot better looking than just an open quartz movement without the added security and stability of a cover. And so I printed a version of that. This doesn't have, again, the cutout for stem and interference, so I went through a process of, okay, here, does this fit inside in terms of where the diameters were for this interior ring, to just kind of get real close and circle around this movement section tightly. And then once you get that fitted, then it's okay, well, how much do I need to cut out for the stem clearance, so on and so forth, and how high do I need this lip so that this sits at the right height, so that it's flush with the rest of the movement holder, all those sorts of considerations, so on and so forth. But you go through that process, and I got to the point where I was like, you know what, I got a little space, a little bit of clearance in here. What if I made a little bit of a notch there so that the cover sits on there, it doesn't want to rotate. Just like we have the notch on the 9 o'clock side, this isn't going to rotate because it's stuck in that little pin. Well, what if I made a notch for this side so that the cover doesn't want to rotate as well? So I decided I'm going to make a little cover, right? So this fits. Okay, well, how high do I need this little notch to be so that it fits in the movement holder nicely, but Also doesn't interfere with the stem. You can see my 2 iterations of that. It only took me a couple prints to do that. Here's the first one. See, I drew the notch out, and this is exactly the right width to go in that slot right there. But it has no extra added height. Then the one I decided to go with after some testing was this one. Again, the width is exactly the same as on the movement holder, but notice there is just a tad more height. There's 0.5 millimeter height added to this, so it feels like a little bit more of a secure connection between the two things. So this, again, we have this interior ring. It will fit nicely snug around this movement circle, and this lip here keeps it at the right height, so this is flush, and this notch sits in between that cutout so that it locks in place. So you can hear that snap. It's now down in place. Again, there's a little bit of extra height there, so that goes a little bit deeper that direction, but there's still plenty of room of clearance for the stem. You can see there's the hole. Boom, right there. Stem will go in nice. And now when the exhibition case back goes on, again, person could put their logo, some other thing. You don't necessarily have to use an exhibition case back, but this is just what this person had for this project, was this case which has an exhibition case back. I'd prefer a solid case back for this particular design, but they can use it for their logo, and that's what they're intending to do. And so there is the movement. Now, again, I don't have an actual dial in here. It's just an old test dial. So this ended up being 3 parts. The ring that's 1 millimeter high to get the movement at the right height. Then I had the actual movement holder that's cut the right dimensions for the Miyota 2035. Pop this all out for you. Dial down. Boom. Take these apart. Movement holder for the Miyota 2035, like so. Boom. And then the cover that will fit nicely with it. And I can show you a little bit more about that. You can see what these kind of look like. 3D printing can be a little bit rough. What's really interesting about this whole project is that the ring, it's smaller, a lot more finer detail. This is printed in ultra high detail. The movement holder is printed in high detail, and the movement cover is printed in standard. This is 0.2 millimeter precision. This is 0.1 millimeter precision, and the ring is 0.05 millimeter precision. Think of it that way. Which is kind of what you just got to print them out and test it at the different levels of precision and see which one seems to work best or is most efficient with your 3D printer. Look at that. Fits in there nicely. See how that works. Movements will sit in there nicely. Isn't that cool? That sits in there like that. The dial will be able to sit flush. That movement's not going to move around anyway because there will be 2 feet, dial feet on that will fit in that location, and that location right there. Dial will sit on top. Stem in there. That movement's not going to move around. It's got some cover. Put a logo on the back. So those are the 3 components that I ended up designing for this project. We got the movement ring, we got the movement holder, and we have the cover. And let me show you how those are drawn up in AutoCAD.
I just want to give you an idea of what it looks like in AutoCAD drawing these components. Now, I'm not going to walk you through all the steps of drawing like the complete holder or the cover. I am going to show you the process of drawing the ring. It's simple enough, and it gives you the idea of the steps for drawing a 3D object in AutoCAD 3D. And then I will move that object over to Cura, which is this 3D printer software, and I'll show you the settings that I use to print the parts. You can see I've got, the rings in here, and just kind of walk you through that process. You can kind of even see, like I was showing you the actual printouts, you can see that same process here sort of duplicated as I copy, save, and move different versions of it as I go along, changing things. Started with the shape of the movement, you can see, using circles, lines, arcs to get the general shape. Then I'll copy that over. I'll take the object like this, I'll join all these lines together so it makes one solid line around. And then the way you create 3D out of 2D, this great little function called press pull. So you can choose something like this, and you can make a 3D surface. Okay? Zoom out here. Again, you can kind of see the process I went through here. This is the sort of primitive first version that fits inside of the existing holder that came with the case. And you can see I just copied this stuff over, did press pull, made it larger. Again, I'll walk you through that process with the ring. There's no cutout for the stem, so then I'll start drawing lines from center. You can see over here, drew a little box, line from center, how wide I want to make this cutout. Let me zoom back out here so you can see there's the first version. Then I got the cutout for the stem, decided, well, I need to cut it out all the way. There's where I cut it, and just leaving a little bit left. And I finally got to the point over here where I had it cut out completely. And what I did was, initially I had this fitting inside of the existing holder. Well, I needed to actually extend the exterior so that it would fill the entire case when I decided to totally replace it. And you can see that I created this ring separately here and this kind of slapped it around the edge to extend it out. Raised the lip, you can see down here, I just drew the ring and set it on top. So this part up here, this part down here, I just added to the existing design I had, and then I used this to create the 3D model, 3D solid model. And then the other thing I did was added the little notch. So we're going to flip around there and then zoom back in. And you can see I added that little notch onto the surface. Again, I will show you sort of basic steps just using the ring as an example. So that's kind of what it looks like in AutoCAD with this part of the movement holder. That's the movement holder. Then I create the cover and the ring separate. Here's the cover. Same process. There was my initial design right here. Simple cylinder with the ring on top. And what I then eventually obviously had to do was make the cutout for the stem, which you can see I did here. And then I added the little notch that's about a 0.5 millimeter, that block sitting on top that will help lock it in place. And you see over here, I've copied the entire movement holder. So there's the movement holder and there's the cover. And let me just show you kind of what this process looks like then when I want to create something. And I'll just use this space to do it. So let's say I want to create the ring. I'm in the drafting settings here. I'm going to say I want to draw a circle. So I'm going to draw a circle, and here I'm moving back and forth. I'm going to hit the down arrow and specify I want a diameter. And the units I'm using is millimeters. So let's say I want this thing to be 33.5 millimeters, which is about the maximum inside the case, actually. And that's the size I used, I believe. So there's my little circle. Now I want to create a ring, so that's the exterior. I want the interior. So same thing. I want to specify the diameter, and I had to make this 1.2 millimeters less. Just 1 millimeter wasn't enough. It wasn't printing that well in terms of quality. And so this is going to be 1.2 less than 33.5. So this is going to be 32.3. Okay, and there's my ring. Now, how do I turn this into a solid object? There's this cool function called press pull. There it is. And first I'm going to raise this interior ring up. It doesn't matter what I put, I just something that's over 1 millimeter high. So I raise that up, and now I'm going to select the outer ring, and I want this to be 1 millimeter high. So I type in a 1, and there's my 1 millimeter. Hit return again. And so there's just a few steps. One, draw the shape you want. Then use press pull to create a 3D object out of the 2D object. And then what I want to do is subtract. So I'm going to type in subtract. And what we're doing is we're going to subtract essentially the interior cylinder from the exterior. So I'm going to select the exterior first, and then I'm going to select the interior, hit return again, and voila, there's my ring. And now I could print that out. Something else I'll show you. Let me do a copy. Let's say I wanted to cut down for a stem. Let me shift over here. I'll just use this as an example. Copy this over. Select my base point, the midpoint here, which I will set to the center of my circle, like so. If I wanted to cut a notch, what I do is I would create a rectangle like this from center, so I know it's at center, and I can choose how far out to the, from center, how wide this particular notch is going to be. And I do that same sort of functionality. I'll do press pull, And now I've got that object, and then I just do the same thing. I do a subtract, and I'll say, well, I'm going to subtract this, this. There's my notch, room for the stem. So that's that process a little bit. Let me undo that. Okay, so now what if I want to export this and 3D print it? So I got my ring. Well, we do export, and then you can choose the file type, and you can see here what you want is an STL file, lithography. Okay, and then you could name it whatever you want. I'm just going to name this test for the moment and hit save, and then you choose the 3D solid surfaces that you want to export to this 3D model. And I'm just going to choose the ring, but just to show you, I could select all of these different surfaces on this movement holder, but I need to select all of them I want included. And if they're right next to each other, you know, in terms of these rings, it'll turn it into a single solid surface. And so I'm just going to select the ring and then hit return. And what that does is that exported that file. So let me show you what that looks like. Here is the test file, and I'm going to hit return, and you can see this is now a 3D ring. Let me show you what a couple other of these look like. Here's the cover. There we go. See, it's got that notch, helps lock in place, cut out for the stem. And then we have the actual holder, which is right here. And you can see it printed out there with the STL file. Okay, now let's see how we print that out. Okay, so what I'm going to do is I'm going to fire up Cura Lulzbot Edition, because my 3D printer is a Lulzbot Mini 2. And I have the micro extruder. There's the regular standard extruder, but I have a micro, so I can print more ultra high detail things when I need to. And so this is just the software, shows the 3D surface, and you can do all kinds of stuff when you get the object in here. But let me show you how I do that. So just take the ring, like I'll use this test ring, just drag it in here, and there's the object, right? And then I can do things like print it out. But let me delete that. I'll put in one that you can see. I can show you a few more things. Let me put the actual holder in here. There we go. And move that out of the way. Then you can see how long it would take to print these different things, depending on your settings. So there's different levels of settings you can choose based on what category you're in. The material I'm using is just a regular old PLA. You know, one of the interesting things about these 3D printed parts on this particular build is that I have three options because I have the micro extruder. I can print in standard detail, and I mentioned this is 0.2 millimeter, high detail, or ultra high detail, which is 5/100ths of a millimeter. And for this build, the three different parts, the cover printed best in standard detail. It's just a simple, you know, flat surface, one little ring in the middle with the notch for the lock. Not too complicated, and actually printed out best in standard. It takes about 14 minutes to print out. You can see the time will change down here depending on what precision level I choose. So it'll reslice it. It'll take 20 minutes if I just print that out in standard. The actual movement holder, I needed to print in high detail for the best results. So this particular component I have selected right now, the actual holder, had to print in high detail. You can see that takes 44 minutes. If I was to move this up to ultra high detail, it may print differently in terms of how it looks, but it would take a couple hours, and it looks fine. It's going to be sitting inside the case. It's going to be hidden anyway. It doesn't need to look perfect or anything, just needs to be accurate in terms of the dimensions, like for holding the movement. I usually have the infill, you know, between 20-30%, something like that. And then the ring is the thing that I had to print in ultra high detail. The accuracy is key. It has to be perfect to fit inside the case, go around the edge, both the exterior and the interior perfectly, and so that that 1 millimeter accuracy in terms of the height, the 1.2 in terms of the width is exact. One thing you can do, you can zoom in on this a little bit too. You can say, okay, what is the different layers in terms of the printing? Say solid view, you can go to layer view, and you can see, you know, what layers they're going to be. You know, rotate the object like this. Like, you know, you could flip it around. You want it printed as flat and cleanly as possible. And that's obvious at the holders, that the solid part of the cylinder is going to be wanting to lay flat. Snap that down like so. So there's lots of different settings depending on your printer. So I'm using regular PLA. Again, for different parts, you might use different types of precision and stuff like that. So anyway, that's what the software looks like. And then I would just, if the printer was hooked in, you can either save to file or it would say print to USB, and I just click print and it would print out to my 3D printer. One of the other things I want to show you is I have a Lulzbot Mini 2, and I mentioned that I've got the micro extruder as well. One of the other things when you're talking about printing different levels of precision or getting quality, maybe it's not working quite right. One of the settings that I have to alter or tinker with the most is called the Z probe offset, or the Z axis offset. And I just want to show you what that looks like if you were getting into this sort of thing, doing it yourself, is in the menu screen on the 3D printer. If you go to the configuration menu, advanced settings, then in there you're going to see a Z offset. And that's, at its position once leveled, how high above the surface is the extruder. And you can change this to certain levels. I found with using the ultra high detail, and the standard in this setup for these specific parts, printing at those levels of precision, that I could use one particular height and the quality came out okay, and that was 1.18. So that's going to vary. This is one thing I change depending on the quality I'm using or the part I'm printing quite often. And I just, make a note of which part and what height and what precision level. That way, if I want to print it out again, I have that saved somewhere. So this is one important setting that I thought I'd mention.
Thank you for joining me in this Making Custom Watches video. I really hope for those of you that are out there tinkering or makers or wanting to look into how you can do this sort of thing yourself, I really hope that you find this helpful. In the description below, you'll find the link to my Making Custom Watches page on my website, watchcomplications.com, where you can see more videos and more information about my stuff and the process of doing this. So yeah, thanks everyone for joining me. I wish you all the best of health. Keep you and your loved ones close, and remember what matters, but always, always have a good time. I'll see you around.